Can we look at 11 and 12?
Absolutely. Yeah, so for 16 in the middle, it's kind of freaking out, oscillating motion. That would be a does not exist because you can't literally predict what it's going to be doing in the middle. Now, which one did you say after that?
11 and 12.
11 and 12. Okay. So 11, some people are getting like freaked out by like the equations. It really doesn't matter. I don't care about the equations. You are finding the limit as x approaches 2. So remember, for something like this, there's 2. To find the limit as x approaches 2, you're going to track in from the left. You're going to track in from the right on the function. So the question on that is, for the limit, does the closed dot matter at all?
No.
No, not at all. So the limit in this case is from both sides approaching 2. Now, if I asked you a completely different question and I asked you what was f of 2, at that instantaneous moment, that's when the closed dot matters, and that's when you would tell me that's 0. 12.
And the open, on number 11, the open circle doesn't matter, right?
It really doesn't matter at all. No.
Okay.
It's, I talked briefly with someone else about this one and a question like that. What happens is, it's kind of the difference in, I use some physics words for it. I don't know what everyone covers in their different physics classes, but it's the difference between like average and instantaneous in physics. When you talk about average speed, instantaneous speed, average speed is basically saying, what is it doing about for most of the graph? That's kind of what a limit is. A limit is like a prediction. So who cares if there's a hole in it? What is the graph going towards at that point?
Is that
the closed dot is your instantaneous. What is happening exactly at 2? Only at 2. What was, did you have a question on that?
Oh, on 12?
Yeah, I'll do 12 too. Yeah.
Okay, so 12 makes sense because that's a circle, an open circle.
Yes. Yeah. So 12
still
is
approaching.
similar to 11, that you're just saying as we approach 1 from either side, your graph, regardless of that hole, is getting closer and closer and closer to 3. If, however, I asked you what was f of 1, that's when the closed circle would matter, and that's where you would put that 1. Okay.
So on like 14, it's, we know it's never going to touch 3. So is that why it do not exist?
Yes, it's that for 2 different reasons. Asymptotes, it always does not exist. But the reality of that one is if you track from the left towards 3, where is that part headed towards?
Negative infinity.
Negative infinity. And if you track towards 3 from the right, where is that part headed towards?
Positive infinity.
And what did we say if the left and the right are not approaching the same number, even though it's kind of a weird number?
Does not exist.
Does not exist. Yep. So that's the real reason for does not exist on that one, because it's approaching different parts. Now, I do want to point out on something like that, if I asked you this question, this is asking me the limit as we approach 3 from the left. Could you say where it's going as it approaches 3 from the left?
Negative infinity, right?
Yeah, you can say that, right? You could also kind of argue for does not exist on that one, because is negative infinity really a number? I mean, kind of, yes, but so those ones we're going to tend to, if you say from the left or the right, give an infinity or a negative infinity. Whereas if you ask for the limit as a whole, then we're definitely going to say does not exist, because they're not approaching the same thing.
Okay.
Other things on this page? All right. Other questions on other homework. We went odds 1 through 23, I believe. And then we did all of the questions 25 through 32. Was that page a little bit more straightforward?
Could we look at a couple of those, like maybe 9 and 13?
Sure.
Because I get a little bit confused about when you're plugging in the 0.
Okay. How about I look at something like 9, and then I'll look at like 19 and over there, because they're a little bit different there. So 9 through like 24 asked you to do the same thing. They give you a value. You are going to find the limit as you approach 0 from the left, the limit as you approach 0 from the right, and the limit at 0. So first off, I would look at my restrictions over here and say, if I'm approaching 0 from the left, which one of these two functions would I be plugging in 0 to, according to these restrictions? Since this one is less than 0, that's my left. Since this one's greater than 0, that's my right. So to do the limit as we approach 0 from the left, I'm going to plug in 0 here, which gives me -1. To do the limit as we approach 0 from the right, I'm going to plug in 0 to this, which will also give me -1. If those two numbers match, that tells me my limit at 0 is -1. If those two don't match, that tells me it's undefined, or it does not exist, excuse me. I hope by picking 19, I'm doing one that actually works out to that, but we'll see. Again, on 19, they give me a number, -2. So that tells me I'm doing the limit as we approach -2 from the left, the limit as we approach -2 from the right, and then the limit, since I'm running out of room, as we approach -2 altogether. Again, I look at my restrictions. The less than tells me that's from the left. The greater than tells me that's from the right. So if I go ahead and I plug in -2 here to the top one, -2 squared is 4 times -2 is -8 minus -2 turns into +2 plus 6. That gives me 0. Then from this one, I'll do 2. -3 times -2 is going to give me +6. -2 cubed is -8, but that's minus, so it's going to be +8. That's going to give me 16. If those two don't match, what does that tell me about the limit?
Does not
exist, right?
So all you have to do is just plug in for the whatever number it is, like the x.
Yep. The main on that section is deciding which one's the left and which one's the right based off the restrictions. And knowing that you have to graph it to figure it out. That's a big thing. Knowing that I don't have to graph that piecewise function to see what it's doing. I can still plug in.
What about on 17?
17. I know with ease. Look at that one. That's a great non-calculator question because you think like, hey, I don't know how to do this. Let's remember some basic exponent rules. If I'm plugging in 0, anything to the 0 power is what?
1.
1. So 1 minus 1 would just give me 0 there. And if I plugged in 0 there, I would have 0 plus 0 minus 1 gives me -1. Since those two don't match, your third answer would be D and E.
Okay, so we don't have to graph any of these.
That's kind of the point of this section. Don't graph.
Okay, good.
Yeah. Any other homework questions that we're not sure about?
In the 25 to 32 section, let's see, I have one.
Usually I have a couple in there. You want me just answers on this?
Yes.
Okay, so 25, limit as we approach -3 from the left does not exist. That's false.
Is it false? Why is it false?
That one, because it says, well, for a lot of reasons, as we approach -3 from the right. So as we approach -3 from the right, could I say what that limit is? Yeah, it's getting closer to 0 right there. Right?
0, okay.
And generally speaking, from the left and from the right are never going to be does not exist. Because typically you can say they're approaching a number from the left or the right, or infinity or negative infinity. It would just be the limit as a whole does not exist because the left side and the right side doesn't match. So typically from the left and the right, we don't have a does not exist.
Okay.
The limit as we approach -2 from the right equals -1. So if I approach -2 from the right, it looks like it's getting closer to -2. Therefore, that would also be false. The limit as we approach 0 from the right. So here's 0 as we approach from the right. Yes, that's getting closer to -1. The limit as we approach 0 from the left is 4. That's a big fat false. And the limit as we approach 0 is 4. Also not true, because we're going to see that they are coming towards different numbers, so that would be a false. The limit as we approach 1 from the left does not exist. This is a case where you could say, here's 1, I'm approaching it from the left. You could technically say that that's going to -infinity. So I would say that's false, because you can say that it goes to -infinity from the left-hand side. You could argue does not exist because of the whole -infinity business. If you limit as we approach 1 from the right is 1. That one's true. And limit as we approach infinity. Ooh, we didn't do any of those yet, but let's just discuss. If we want to find the limit as x approaches infinity, first off, what part of this graph would we be looking at? As x
right.
Infinity, right. So that's literally saying as it goes out this direction, what's it doing? So what did it say? The limit as x approaches infinity is 3. Any opinions on that?
True.
Because if you head off to the right here, do you know, well, think in behavior. As we go off to the right, where's the y values going there?
Infinity.
Infinity, right? So that would be the only answer for that one. That as x goes to infinity, y is also heading off to infinity. So that one will also be false. Okay. Other homework questions? Alrighty, we're gonna get to our favorite part of limits, which is using algebra. And I don't mean that sarcastically. I mean, this is like, okay, we know what we're doing with this, generally speaking. So as we kind of pass by this in our notebook, I do want to remind you page 285, great practice. Great practice, AKA be able to do that for your quiz next week. I'm not saying that exact page, I'm just saying a good one. I like that page. All right, so limits algebraically is where we're going to hang out here for today and then next class, which will be Monday and Tuesday for us, 8AB day. Just before I get to that, your quiz is on Monday, Tuesday next week. I believe I have that scheduled right in my PCA. I'm currently working on writing it now. It will only contain stuff from last class, which is finding limits from graphs. So do expect, that's why I said like be able to do something like page 285. I will find a big graph and I will make you do the limits on it. There's a way to do it on Canvas and I've figured it out because I'm a genius. So we will have that stuff and then we'll have stuff from today because today is pretty straightforward. But I'll be on at like 9 to do questions on this homework. So if you were confused on anything on this, then we can do that before you take your quiz because your quiz will be open for second period all day Monday and for fifth and sixth period all day Tuesday. Also just the format of it. If it's stuff on a graph, there's no need to show any work or explanations for that. So I've kind of labeled the quiz that way. Like show your work and explanations for everything except the on the graph, the limits on the graph problem. And I'm still going to have you upload your work at the very end. But this one's a little bit more straightforward with being able to plug in like number answers because there's not the pies and all that stuff that we had in the last one. So it's pretty easy to type in answers. All right, so limits algebraically. So here's the good thing. If you have a function, like an actual equation for any function, just like we saw on the piecewise functions, the easiest way to find any limit, if at all possible, number one, all the time, plug it in. Also known in technical math terms as direct substitution. In other words, unless you cannot get an answer for a limit, when you plug in a number, you may always plug it in. That is totally fine. Now, that's not always going to work for us, and we'll see why in just a minute, but that's always going to be step number one for you, okay? So first thing you try anytime. So let's take a look at example 1 here. Find the limit of f of x equals x minus 5 as x approaches -1. First, let's just practice our notation. Limit of the function x minus 5 when x approaches -1 means that underneath my limit notation, I'm going to say x arrow towards -1. So practice good limit notation here. You need to tell me what number it's approaching. You need to tell me what the function is. What we just talked about is if it's not a tricky function in any way, shape, or form, always try to plug it in first. As we get into some of these, you're going to get better and better at recognizing the ones that you will not be able to plug it into or numbers that would give you a problem. For example, I know this is a line and I know what a line looks like. Are there any holes or asymptotes or any other weird behaviors in a line? No, right? So that means that as x approaches -1, I can simply plug in -1 for x. My limit equals -6. Done. End of discussion. Any issues with that? All right. Do expect at least one question to be exactly that easy on the quiz. Just plug it in, see as far as you can go. Same type of thing on example 2. This one's asking me to find the limit of this function as x approaches 3. Any issues with plugging 3 into this one that you could see? No, but this equation should give you a little bit more of a pause on plugging in numbers. Anyone recognize in that equation what numbers are going to be bad straight off the bat for us? One particular one. Any ideas?
Like on example 3?
On example 2, there is one number, and it's not 3, but if I plugged one particular number in for x, what would be the bad number?
1, right?
Right? So can I plug in 3 to this? Absolutely. If they asked me the limit as x approaches 1, I would have little alarm bells going off in my head. I'd have to figure something out. All right, so plug in 3, totally fine. You get 3/2, 1.5, either one, fine. Any problems, questions, concerns? All right, so the moral of that story is, if at all possible, plug in your number. It can be very possible. Then we start running into questions like example 3 and example 4. And before I do those two, I'm going to go to this little table down here. It's kind of like a flow chart. This is some of my little mental, like, what do I do for limits? So number 1, always plug it in if you can. And then this all together is step 2, because depending on what kind of question you're looking at, you're going to try different strategies. And there is actually a third one that we're going to see in that same line here. So we're going to have some options. So if you plug it in and you don't get a good answer, here are your options. You can factor, you can multiply by the conjugate, or I'm going to add a third one in here. You can simplify fractions. And all 3 of those, notice, go back to plug it in after you kind of fix up the equation. So let's see what that looks like in example 3. First off, what we said all the time is plug it in. So if I want to find the limit of the function as x approaches 2, all right, so I'm going to write out my notation here. Limit x approaches 2 of x minus 2 over x squared minus 4. Anyone see what's going to happen when I plug in 2 here?
No, the 0 on the top, right?
0 on the top and?
0 on the bottom.
0 on the bottom. Which one's the problem?
Oh. The bottom.
You may certainly have a 0 on the top. 0 on the top with a number on the bottom. The answer is just 0, and you can have a limit that's 0. The issue here, the big blaring problem, is this guy. That is what makes it indeterminate, what you see down here. In other words, there's no answer to this right now. That's not okay right now. because there are things that I can do to try to fix my equation. So looking at our options that we wrote down here, we said we could factor, we could multiply by the conjugate, which we've talked about before, but you probably don't remember, or you could simplify complex fractions. Anyone want to take a guess at which one we're going to try here?
Factoring, maybe?
Factoring, all of our favorite. Factoring never goes away. So let's take a look at our function f of x right here. What can I factor?
The bottom.
The bottom. And if I factor the bottom as a difference of squares, I get x plus 2, x minus 2. Now, what does that do for me?
Cancels out the x minus 2.
So now I have a simplified version of my function, 1 over x plus 2. This is an equivalent version of f of x. It was something we did a legal mathematical move to. So now I can take this function, go back, and say, now with this simplified version, can I now plug in 2? I'm going to use my simplified version, 1 over x plus 2. If I plug in 2 to that, can I do that? Now that I've canceled the x minus 2's top and bottom, now I get an actual answer when I plug in 2. Okay? What that means is, if you remember back to the rational functions we did in the fall, when we canceled factors top and bottom, what was there in the graph? Anyone remember that?
A hole?
Yes. If there is a hole in the graph and you can cancel it out, you will be able to find what number that your graph is getting closer and closer to on either side of that hole. It's what we saw in our graphs. It's something like this. You would have seen a hole in there. So yes, you can predict what it's getting closer and closer to if you cancel that hole out. That works great. Well, now this question asked me to find 2 limits, right? It also asked me to find the limit of f of x as x approaches -2. If I try that, I'm running out of room here, on my simplified function, is that going to be okay? Can I put in -2 there?
No.
No. What am I going to get on
A 0 on the bottom.
0 on the bottom? Okay. So here's what we learned from that. Sometimes factoring and plugging it back in works, and it did for the limit as we approach 2. Sometimes factoring and canceling out, depending on what's happening in the graph, does not help us. Okay. Now, for the sake of argument, because we are all online and doing lots of fun things right now, I'm going to show you what this graph would have looked like and why you're still getting an error at -2. If we have factors that cancel top and bottom like we saw, okay, so we simplified this function down and we canceled out factors, that meant we had a hole in the graph at x equals 2. But our simplified version is 1 over x plus 2, right? Anyone remember what we get if we set the bottom equal to 0? What parts of the graph were those?
Was that an asymptote, like a vertical asymptote?
Yep, it's an asymptote at x equals what?
-2.
-2. So just kind of a brief sketch of what this graph would have looked like. We would have had a branch up here with a hole at x equals 2. And I probably shouldn't have drawn that branch there. It should have been going further over to this. There was a vertical asymptote of -2. So we probably would have had another branch over here. So now thinking about that graph, why does it make sense that I still could not find the limit as x approaches -2 by plugging it in? What's happening on both sides of -2?
They're going in different directions.
Yes. Okay. They are still going in different directions, which means what would we say about the limit of f of x as x approaches -2?
Doesn't exist.
Yes. Okay, so you can still get does not exist from these.
So for the -2 one, it does not exist, but for the +2, it's 1/4.
Yes, ma'am. Exactly.
Okay.
So here's kind of what this flow chart tells us. Going back to my flow chart for a minute. Always try to plug it in first. If it doesn't, try one of our 3 methods that we're going to talk about today. I keep rewriting this. I need to add it in permanently. Simplify complex fractions. We said after you simplify in one of these 3 methods, just like we did at 2, we still try to plug it in. If it works, great, you have an answer. If it doesn't work, this is kind of your last resort. Check the graph. Okay, that's kind of what we did without pulling our calculators out for -2. That's how we determined that it does not exist. So if you plug it in, even after simplifying, and you don't get an answer, that doesn't necessarily mean it has to be does not exist. You still have to check your graph. So always check your graph before you say does not exist. In that case, we saw one side of the graph was going to -infinity, another side was going to positive. Oftentimes, that's what's going to happen. But we've also seen vertical asymptotes where they're both going in the same direction. If they're both going to infinity or they're both going to -infinity, you can still tell me that as an answer as well. So don't assume does not exist until you check your graph. Okay? So let's try that again with example 4, and then we're going to finish up with a couple different examples here on conjugates and simplifying complex fractions. So example 4, if we just real quick check, mental check, if I plug in 1 here and here, that's going to be 1 minus 4 plus 3. What's that going to give me on the bottom of the fraction?
0.
0. Are we allowed to have that?
No.
No. Okay, so notice I'm not necessarily showing all of my work on that. If you can kind of mentally check, can you find the limit as x approaches 1 by plugging it in the way it is? No. Okay, so then go back and try one of our methods of simplifying. What can we do to that function in order to simplify it?
You can factor the bottom.
You factor the bottom. Factoring should kind of always be where your mind goes to immediately because it's so familiar with us. So we say x and x, factors of 3 are -3 and -1. What does that allow me to simplify?
Cross out the x minus 1.
Okay, so it crosses out my x minus 1s. I have my simplified version is now 1 over x minus 3. So let's go back. Now let's try to do the limit as x approaches 1 of our simplified function. Can I plug in 1 to this simplified function? Yes, I can. And it gives me 1 over -2. Because that factor of x minus 1 canceled top and bottom, that's what tells me that there was a hole in the graph, and I'll still be able to find my limit algebraically. Now they asked me to find a second limit of x approaching 3. Still going to use my simplified version, but am I going to be able to plug in 3 to it? No, because I'm going to get what on the bottom? 0, right? If I plug in 0, or if I plug in 3 to my simplified version to find that second limit, I'm still going to get 0 on the bottom. So I would go graph this, check what my graph looks like. Again, you would see something that has at 3 a vertical asymptote. At 1, we had a hole in our graph. Let's check what that would have looked like. It would have been something like this. Again, like I can pull most of this out of my head. I probably would just expect you guys to graph this on your calculator. So I would have some graph that looks like that. What happens as we approach 3 from the left? It goes to -infinity. What happens as we approach 3 from the right? It goes to +infinity. So what do we say about the limit as x approaches 3?
Doesn't exist.
Does not exist. So sometimes, just like the last one, factoring and canceling fixes the problem. Sometimes, just like the last one, it doesn't. So there's never and this is what will drive some of us nuts about limits, there's never one way to do everything. It just isn't. So we have basically what we're going to learn in limits is here's these different tools to try. Try to factor, try this, try this. If all else fails, check your graph, see if it works. So as we do limits, we're just going to kind of add in different tools. All right. So we're going to see the same thing here on example 5. Again, it gets easier and easier as we go through. Take a look at this question. Anyone tell me, am I going to be able to plug in 9 to this?
No, because there's square root of 9.
Yeah, I can see I'm going to get 0 on the bottom. Pretty easy for me to see, so I'm not even going to show that. So I'm going to go back to my flow chart here and say, okay, if I plug it in and can't get an answer, I can factor, I can multiply by the conjugate, or I can simplify complex fractions. We've done factoring. Conjugate is what we see here in example 5. Conjugates involve square roots every time. All right. So here, and obviously, can you look at example 5 and realize that you're not going to be able to factor that?
Couldn't you just do 3 plus square root of x times
Exactly.
3 minus square root of x?
So that's exactly what multiplying by the conjugate is.
Oh, just kidding.
Yeah, no. So, I mean, that's exactly what we're going to do. So what you do is you basically say, I can kind of fix this up if I multiply by what is called the conjugate. It's never just the top or just the bottom. It's always the one that has the square root in it. So I look at whichever one has the square root in it. The conjugate is the exact same thing as that, but you switch the sign in the middle. And if you do this, you have to do it to the top and the bottom at the same time. Because essentially, I'm multiplying by a form of 1 right now, okay? Now, a couple rules of thumb for multiplying by the conjugates. Number 1, you always multiply by the conjugate of the one that has the square root in it, always. Doesn't matter if it's on the top or like we're gonna see in example 6 on the bottom, you always multiply by the conjugate of the part that has the square root. Secondly, you will only FOIL together the conjugates. So in this case, I am going to FOIL together the top. I am not going to FOIL together the bottom. You're going to see why in a minute, okay? So let's just see what this does for me. If I FOIL the top, 3 times 3 is 9. Outer terms is 3 root x. Inner terms is negative 3 root x. Last terms, what's negative root x times positive root x? This one, that times that. Negative x. Good. Now notice on the bottom, not FOILing together. Sticking them next to each other. Now let's simplify the top. What's going to happen?
And positive 3 root x and a negative 3 root x.
Yep. And that's going to cancel every single time. That's the purpose of multiplying by the conjugate. Otherwise, okay. Now let's notice to ourselves, what do we have
9 minus
on the top?
9 minus x.
Yeah, now I can cancel that.
Also cancel.
Which is exactly why I didn't FOIL the bottom. That's what you're going to hope happens every time you multiply by a conjugate. I'm going to hope something's going to cancel top and bottom so I can have a simplified version of my function. Now, just like when we factored, we're not done. Once you simplify, we go back to the beginning and say, what am I finding the limit of? Now I'm finding the limit as x approaches 9 of this new simplified function. Now can I plug in 9? All right, let's see. What is the square root of 9? 3. 3 plus 3 gives me the 6 on the bottom. Yes, I can get a number answer from that now. Questions, concerns, problems with that? All right, let's do that one more time, and then we're going to hit complex fractions real quick because you have some space down here that I'm going to shove an extra example or two into. It will be done. On 6, again, if I recognize right away, if I put a 2 in here, even though the bottom's kind of nasty, that's going to make root 2 minus root 2. What's that going to give me on the bottom? 0. Can't have that. Therefore, I'm going to fix this without even plugging it in because I kind of mentally plugged it in. So again, anytime you see square roots like this, also can't factor this, you should think, do the conjugate of this. Now this time, the conjugate will be of the denominator because the denominator is the one with the square roots in it. So what am I going to multiply by top and bottom here?
Root x minus root 2.
Okay, and you change the sign in
plus root 2.
root x plus root 2, top and bottom. All right, now which ones are we going to FOIL, the top or the bottom?
The bottom.
The bottom. You always FOIL the conjugates. You always do not FOIL the non-conjugates. So I'm going to leave the top as 2 minus x times root x plus root 2, because trust me, you do not want to multiply together the top and have to then figure out how to factor it back out. It's ugly. So let's multiply the bottom. Root x times root x is x. Do I really care what either of those are when I multiply the outer and inner terms? I mean, you could make it root 2x and root 2x, but what's going to happen with the outer and the inner terms?
They're going to cancel.
They're going to cancel, and if you don't want to show me that, you don't have to. It's okay. I would love for you to be able to skip steps here, okay? Which means when I do the conjugates, I care about the first times the first and the last times the last. So what's negative root 2 times positive root 2? Minus 2, right? Uh-oh, what's our problem here? Can I currently cancel the way it looks?
Nope.
No,
Negative.
However, could I fix it so that I can?
You can multiply by like a negative 1. Right?
I can multiply the bottom by a negative 1. The easier way is to literally take that and factor out a negative 1.
Oh,
If I pull a negative 1 out of that, it's going to make it positive x and minus 2. Just kind of a hint with the conjugate business. If you get to this place, don't be like, oh, I guess it didn't work. I'm not going to just give you all these random equations that don't work out. There's going to be a way to very quickly fix it, just like this. Now what can I do with my x minus 2's? Cancel. So I am left with negative, and I'm going to distribute the negative in just for the sake of argument. There's my simplified function. Am I done here is the larger question.
Nope.
Because just like all of them, you go back and plug it in the beginning. So now I am finding the limit as x approaches 2 of this simplified function. Once you plug it in, that's when you can drop your limit notation. So plugging into now, I've got negative root 2 minus root 2. Quick review of square roots. What's negative root 2 minus root 2?
Minus 2 root 2.
Yes. Negative 2 root 2. It's like combining like terms. There's a 1 out front of each one of these. It's negative 1 minus 1 gives me negative 2. Keep the root 2 part. Okay.
Good question. So whenever we canceled out the x minus 2, that means there's a hole at x equals 2, but we're still finding the limit for x equals 2.
Yes.
So we don't acknowledge the hole because the limit is the prediction.
Yes. So essentially, let me make it believable here. I don't know what this looks like really, but essentially that's what you've got. Can you still make a prediction about what your graph is getting close to? Yes, even though there's a hole. The ones you're not going to be able to make predictions about are asymptotes. They're ugly. But all right, last method, because if you're tracking with me, we've done 2 factoring, we've done 2 multiplying by the conjugates, and then I added that third method in, which is simplified complex fractions. So I'm going to make example 7 here for you. We have, for example 7, the limit as x approaches negative 1. This is where you see my laziness, because every year I tell myself I'm going to make this better. And every year I don't edit my notes. Is it going to happen this year? Heck no. When we are done this year, we are going to be done. All right, so this is what I have. Remember these complex fractions that we loved so much? Aren't they wonderful? Yes. What is the problem right now with finding the limit as x approaches -1 of this business?
There's a 0 on the bottom.
0 on the bottom. Do you kind of see the theme of all of these?
Yep.
All of that is a problem? Yes, it's often a problem. So what we have to do is we have to simplify the complex fractions. What that means is, if you remember how we did this in the fall, when we did complex fractions, we just took everything and we multiplied everything top and bottom by all of the denominators. Okay, so let's see what happens. And by all of the denominators, I mean these guys. So I'm going to multiply by x minus 4 and x plus 4 here on the left fraction. And where else am I going to have to do it if it's going to be okay?
The bottom.
Bottom. Now, does it seem like a good idea to FOIL everything out on the bottom right now? Probably not.
Hopefully not.
Let's just walk through this and be a little bit smart about it. So take a look at this right here. What is that going to do for me, multiplying by x minus 4 and x plus 4?
X minus 4 is cancel it.
Yep, so I'm not going to have double fractions. I'm just left with an x plus 4 and a 1, which gives me x plus 4. Let's see what happens over here. What's going to cancel on this one?
X plus 4.
And I'm going to go ahead and distribute this -2 to the x minus 4. That's going to give me -2x plus 8. And just like we said, it doesn't really seem like a smart idea to FOIL out the bottom, so I'm not going to. Seems like a lot of work. Let's keep working on the top. What are we going to get here if I continue to combine like terms? -x. Oh, does this one work? What happened? Did I do something wrong? I have a -x and a plus 12. Oh, Lordy. This is what happens when I find my examples that I need to do. I did not. Maybe I didn't write this down. Oh, dear God. Okay, sorry, guys. I'm going to back up and give you a different example because that one does not even work. Good times. Things happen. I apologize. All right, let's try a different one that does work. This one will. All right, and it's a little simpler. Limit x approaches 0. 1 over x plus 4 minus 1/4 over x. Same process we did on the last one. We've got double fractions, can't plug in 0 the way it is right now. So we're going to go ahead and multiply everything by both denominators of the complex fractions. So x plus 4 and 4. And just like before, we're going to multiply it on the bottom and not FOIL it out. So let's see. Now this one, the x plus 4's cancel, which leaves me 4. This one, the 4's cancel. Now, careful on this second term. What am I actually multiplying into that x plus 4 that's left?
Negative.
Negative. Okay, so I'm going to do -x minus 4. And on the bottom, I have an x, I have an x plus 4, and I have a 4. So continuing to clean up the top here, what's going to cancel on the top?
4.
4's, which leaves me a -x. Now, what else can I cancel?
That x, -x.
X on the bottom, right? So essentially, the simplified version is -1 over 4 times x plus 4. Now, if you want to distribute that, you're welcome to do it. But just like all the other versions, once you simplify this down and have another version of this fraction, what do we go back to doing?
Plugging in the
Go back to the beginning
limit.
and plug in the limit, right? So now I'm finding the limit as x approaches 0 of 1 over, -1 over 4 times x plus 4. Can I plug in 0 here? Yes, I can. So what happens with that other one when I make up examples? works out great. I love that. Do we want to do another complex fraction example? We tend to hate those. Any opinions? No opinion.
Did they get any worse? Like, how could they get
no
more problematic?
Those can't get horrible because they have to work out nicely. There's not a lot of them. Like, I struggle to find good examples because if I try to make them up, it takes a lot of working backwards for me to make them work right. So they're ugly. Not that they get harder. I just mean that there's not a lot of them out there, honestly. So, speaking of, what did I say for homework? So let's look at this. I need to remember what I gave for homework. On the list for the homework today. It's much more algebraic, so we tend to like that a lot better. We have, pull up my grade book. Also, if you were one of my lovely friends that had funky grades, again, I finally got with Canvas support yesterday. They had to figure out what the heck was going on. I graded, I think Macy, Blake, and Nick, it happened to you guys. Nick was the one that found it for me. I graded your homework, it was 100, and then all of a sudden, Nick has a 66, and Macy has a 55, and Blake has a 38, and I'm like, what is happening? Canvas is like randomly updating my grades to not be what I gave them. So we had to do some tech support. Not PCA tech support. It was Canvas. Canvas itself. All right, so limits, what did we do? That's homework 9.1. Let me see. Homework 9.2 today is pages 291 and 292. So that being said, what is 291 and 292? Actually, not this. So what I left this limits worksheet right here, 289 and 290, that can be extra. What I would say is, like, if you need extra conjugates, that's 8, 9, and 10. If you need extra factoring, that's 4 through 7. If you need extra random plug it in ones, that's like 1 through 3 or something like that. So use those if you need them. But the homework is going to be 291 and 292. It seems like quite a bit. A lot of it's very basic factoring. And remember that there are a lot that are just plugging it in. On 292, this bottom section I'm looking at, this is really good practice with that piecewise functions stuff that we did already. So that's great review for your quiz. So that's kind of my intention with it being a little bit more homework than normal, is practice, plug it in. If it doesn't work, factor or conjugates, or simplify the complex fractions, but also practice what we did before with the piecewise functions and knowing which part to plug it into. So for like 13, on this one, if I want to approach 1 from the right, which of the 3 boundaries does 1 fall into? Okay, so it's just that top one, right? So that's all really good practice for your quiz. So 291, 292, there's a couple complex fractions on there, a couple foiling. Yeah, so on something like question 4 on 291, you may have to FOIL out the 2x plus 1 squared first and then simplify and factor. But it's a lot of basic algebra. So there is that. There's complex fractions, there's conjugates, there's kind of everything on these 2 pages. This is, we will continue with this next class and add in some trig stuff, but that's basically the gist of it. Okay.